Hello guys, welcome to Friends in Tech Automation. We provide practical training on PLC, SCADA and IoT. Welcome to another episode of PLC programming. And our topic today is arithmetic operations. Arithmetic operation is still a technique for handling data in PLC. So data handling, we say that we have different techniques. One of them is data movement, data comparison, now arithmetic operations. So arithmetic operations, some PLCs are equipped to carry out just arithmetic operations of addition, subtraction, while others have addition, subtraction, multiplication, division, exponential, absolute, sine, all trigonometric functions. Now, arithmetic operation is very important when you are doing mathematical calculations in PLCs. For example, you want to do speed calculation of using an encoder. So you have this digital sensor, an encoder. It can be incremental or absolute encoder, and you want to calculate the speed of a motor. So you have to do speed calculations. Another example, if you are in a power plant, you want to know power that is being generated, active power, apparent power. You want to know power factor. So you can do those calculations using arithmetic operations. So how can you use these operations in PLCs? So the first thing, open your project in TIA Portal here, and let's call this network number 20 arithmetic operations, and we want to do power calculation. So an example we want to use here, we want to do power calculation. So we want to do power calculation. So here we want to do power calculation. Power calculation. So you need to watch our previous video on data movement, data comparison, and most importantly, you have to watch our previous video on subroutines using function control block, Siemens function control, that is TIA Portal function control, FC block. So we said for calculations, you need to use FC. So you have power calculation. So you need to calculate power. So let's just start with apparent power. So apparent power is equals voltage. Let's just use single phase. Voltage times current. And let's say our system is using power factor. Power factor of our system, PF, is equals 0.98. That's the power factor of our system. That means that for you to get active power, you need this apparent, then you have to multiply this by power factor. For you to get reactive power, you need to take apparent minus active. Some people call it true power or real power. So these calculations, you can perform this using arithmetic operations. So let's go back to TIA Portal here, and let's label this arithmetic operation. Arithmetic operations, that's it. I just stop this, I don't need this here. Arithmetic operations, you have it here. So the first thing I will do, I'll go to program blocks, then I'll add new block. And this time here I want to add FC, just a subroutine, and let's call it power calculation. Power underscore calculation. That's it. Then just hit OK. I don't need this guy here. Just a minute. I don't need this guy. So this is our empty power calculation block here. So this is things we need to do here. So in network number 1, we want to calculate apparent power. Apparent power. So here we need to calculate apparent power. So how do you calculate apparent power? Apparent power, you just need voltage times current. So I'll go to block interface here. Then I'll create temporary variables or placeholders, and I'll create voltage, an input. You need an input voltage, and here this voltage will be real. So you have to change data type here to real. So real is used for floating point numbers. That's it. Then add another. So we need current. We need current. That is real as well. Then at the output here, we need apparent. So that will be apparent power. That will be apparent power. Let's just write it full. Apparent power. Then also we'll need reactive power. I'll need active power. That's it. And this cannot be Boolean, it has to be real. So you have to change this to real. You have to change this as well to real. Then here we need also reactive power. So you need reactive power. That's it. This will be real as well. Then you need power factor. You need to provide power factor. PF. It will be real as well. That's it. So those are the placeholders that you need there. Then you can just close this block interface. So the first thing, to calculate apparent power, what do you need? You need go to math functions, then drag multiplication and place it here. So here we need to multiply a voltage and you need to multiply current. That's it. And output here will be what? Apparent power. That's it. So in network number 2 here, we need to calculate active power. Active power. Active power. So here you need also to drag multiplication. That's it. And you need what? So active power, you need apparent power. So you need apparent power and power factor, PF. That's it. And output will be what? Output will be active. That's it. So in network number 3 here, you need to calculate reactive power. Reactive power. And what here, reactive is subtraction. Just subtract, so you can drag subtraction block here. And you can take apparent total power minus reactive power minus active. Then output will be what? Will be reactive power. And that's it. So that's how you can use arithmetic operations here. So you have just utilized multiplication and subtraction. You can have addition, division, modular, you can have negation, absolute. So after developing this here, you have to go to DB data block 1 here. And let's just create those. Let's create voltage. So we'll just use some dummy values here. So voltage real. And we can start with a voltage of 230. So that will be 230.0. And current here we can give a current of let's say 15 or even 10. 10.0. That's it. So if you go back to main here, so the only thing you need to do is call this power calculation block. So you can just drag it here like this. Then you need to add voltage. So also here I'll add apparent power. Add apparent power. I'll add reactive power. I'll add active. That's it. So you go back to main. So here you have to assign voltage. So go to DB, data block 1. Go to data block 1, then select voltage. Where is it? Can't see voltage, I can only see current here. Data block 1 don't have voltage. It is here. Real. Check in power calculations if voltage was given real. Voltage real should be working. Let's check that again. Where is voltage? Oh, here, voltage. Then here is current. Data block 1, current there. Then power factor. Okay, we need to assign power factor. So you can give it 0.98. That's it. Then apparent power. DB1, apparent power. DB2, active power. DB1 I mean, active power. That's it. And finally here we have reactive power. And that's it. So let's try to download this program. Select consistent download, then load. That's it. Then take your CPU to run mode. That's it. Then go online. And this is what you're having. So if voltage is 230 and current is 10, so that means apparent power will be 2300. 230 times 10 is 2300. So 2300 times power factor of 0.98 gives you 2254. That is active power. Then reactive power is only 46. I mean, that's how you can use arithmetic operations. That's how you can use arithmetic operations. So this is very important. So you can use it in calculations, power calculations, speed calculations, and so many other applications, industrial applications. So if you enjoyed this video, give it a like, share, and leave a comment.